So Tato, welcome back. Next question on OpAmp. So what do we got here? I want to go over this in a little bit of detail for you. So what we've got is we've got our model again, okay? And what I want to do now is just encourage you to think about what are these two inputs for, okay? Why do we need two inputs? Well, what we've got is a model for the output here, that how that is described is some sort of amplification factor A, which we know, I've told you, is really high, 100,000, okay, at least. And then it's multiplied by the difference in the two voltages. So let's have a look at this, V plus minus V minus. So what is this? Well, here's our non-inverting terminal, and the voltage applied to the non-inverting terminal I refer to as V plus. So you'll see that around place, V plus, okay? V plus, V plus. So this superscript. Now V superscript minus is the voltage applied to the inverting terminal. Okay, so what's happening here is that the output voltage for our device is based upon the amplification factor times the difference between these two inputs. So this is like this input minus this input multiplied by 100,000, or whatever A is, the amplification factor. That's our output voltage, and that's the really important thing that you need to understand about these devices. So if we go down here to the simulator, what you can see here is I've got 150 microvolts on this input, I've got 152.4 microvolts on this input. So that means that the difference between these two is, let's just be really careful, it's 150 minus 152.4. That means that the difference is minus 2.4 microvolts, okay? So that's what is amplified. It's this input minus this input, okay? That's what's amplified. And then as you look at this question, you'll just be able to fill in this table here without too much difficulty, looking at the difference between the non-inverting and the inverting input voltages, and then multiplying them by 100,000 or whatever A is given to you in this particular example. Cheers.